Well, we've got a monster topic here tonight in Algebra 2 Trig. We're going to tackle a topic called complex fractions, and as the name suggests, it can be quite the challenging topic. And this is just one example here that I've imported of what our problems tonight are going to look like, and they're very, shall we say, overwhelming. There's a lot going on. What you'll notice here is, this right here, and I'm going to change colors here. This right here is our numerator, of course. And then everything down here is our denominator. And what makes them complex is the idea that just within the numerator, we've got what we call these minor fractions, okay? And then just within the denominator itself, we've got more minor fractions. And of course, that could always be written as one, even if it isn't. And so we've got what we like to call the primary, the big major fraction, and within it are all these little minor fractions. So we're going to have some new terminology to get used to tonight. All right, well, now's the time in the lesson that we want to just get some of our formal definitions and guidelines out of the way. So get that pencil and pen fired up. We're going to do some writing before we tackle some live complex fraction problems. But by definition, complex fractions are simply defined as fractions that have other fractions within their numerator or denominator. All right. So we're going to get this all spelled out here. Hopefully I can spell these rascals right. So just to recap it, complex fractions are simply defined as fractions that have other fractions within their numerator and or denominator. Now, to simplify these fractions, and that's really what our task is going to be tonight, is to just simplify all these complex fractions, means to remove these minor fractions and then eliminate any common factors there might be. So there might be some canceling to do at the end, which is pretty common on the Regents exam question. So we just want to remove all the minor fractions. And then here's the big key. Here's the one thing that I want you to really highlight in your notebook and put some asterisks around. The key here is to remember that what are we really multiplying by? Just like we were when we were adding and subtracting fractions and we were trying to create these common denominators, we're just multiplying by the number 1. It's going to be in disguise. It might not be, it's going to be like 2x over 2x, or it's going to be, x plus 5 all over x plus 5. But the key is that 2x divided by 2x is 1, and x plus 5 divided by x plus 5 is 1. And so we're really multiplying by a value of 1. So now I just want to go over kind of a recipe or some general guidelines, some steps that we're going to use on each of these problems. Number 1, what we're going to do is we're going to identify the least common denominator. All right, and you're probably wondering, well, how are we going to identify the least common denominator? Well, what I want you to look at is I want you to look at the denominators of all the minor fractions. All right, just take a peek at each minor fraction, and by looking at those denominators, we're going to identify the LCD, the least common denominator there. All right, now once we get our hands on that least common denominator, we're going to multiply the major fraction, which is the one big rascal sitting in front of us. All right, there we go. We're going to multiply that major fraction by what? Well, the value of 1. But the value of 1 is going to be the LCD divided by the LCD. So it's going to be a 1 in disguise. Now what that's going to do for you, once you multiply by 1, that's going to remove all of the minor fractions that we talked about on the last slide. All right, so we're going to remove all the minor fractions. So once you get those rascals removed, then step 3 is probably going to be our favorite step. What we're going to do is we're just going to make sure now the new fraction is factored completely, and then we're going to reduce it as it becomes available. It's not every single one's going to be reducible, but a lot of them will be. Well, it's finally time to get this party started here, so let's take a look at a live one. And this is a very basic one just because there's no variables in play. But I think you can agree that this is one big complex fraction. Within it, we've got a minor fraction of 1/9. We've got a minor fraction here of 1/18 and another minor fraction of 1/3. So we wanted to say, hey, if you look at the 3 minor fractions, what's your least common denominator? So looking at a 9 and, an 18 and a 3, I'm going to say my LCD equals 18. That's the smallest number that all 9, 18, and 3 all divide into. Now in part B here, they want us to multiply the numerator and the denominator of the major fraction by our answer in part A, which was the 18. So here's what it's going to look like. I want you to use square brackets, and I want you to line this new fraction up right with the original one, and we're going to say we're going to multiply it by 18 over 18. Now what's going to happen is I've got to distribute this 18 to both terms on top and all the terms on the bottom. So I want you to take your time, we're in no big rush, and here's how I want you to rewrite it. As we're distributing, I want you to say 18 over 1 times 1/9 plus 18 over 1 times 1/18. And then on the bottom, it'll be 18 over 1 times 1/3. All right, now we're going to get a lot of things to cancel out. We say, well, the 9 becomes a 1, the 18 becomes a 2. We're just reducing. 18 and 18, they both become 1s. The 3 becomes a 1, and the 18 becomes a 6. So here's how we clean it up. If you want to multiply these two rascals together, 2 times 1 is 2, and 1 times 1 is 1, of course, so I get just a 2. This fraction gives me a 1, and this fraction gives me a 6. So we've successfully eliminated all of the minor fractions. Of course, if I add the two terms in the numerator, I'll get 3, and then I reduce, and I get 1/2, and that's my final simplified complex fraction. Now there was a part C to this question, so we'll scroll back up and we'll tackle it here. They said, oh, why is it acceptable to perform the operation in part B? What number did you effectively multiply by? Well, we multiplied by a 1. That's what I want you to remember. The 18 over 18 was a 1, and that's why it was legal, because 1 times anything is the original stuff. So we really haven't changed the value of the complex fraction. We're just changing what it looks like, and we're rearranging it, so to speak. All right, I promise. This is the last one where we're going to write out any definitions or anything. Then from this point on, it'll just be live problems. But by multiplying the major fraction by 1, by using the least common denominator, that's where the 1 comes from. Whoops. Better start over on the spelling there. By multiplying by the least common denominator, we always eliminate the minor fractions. So that's one thing, that's our big goal. Keep that in mind. Our goal is to eliminate those minor fractions. And if we didn't eliminate them completely, then we know we probably picked the wrong least common denominator. We've got to go back and try it again. All right, so let's try these rascals here. We're going to simplify these complex fractions, and what I'm going to do is I'm going to identify my LCD. And what I'm doing is I'm looking at the 2, I'm looking at the 10, and I'm looking at the 5, and it looks like 10 is going to be my least common denominator. So I'm going to multiply by 1. Remember, this sucker is simply a value of 1. And I'm going to distribute the 10 to both of the fractions on top and the 1 on the bottom. And as I'm rewriting those, it's going to be 10 over 1 times 1/2. Minus 10 over 1 times 1/10. And then on the bottom, we just get 10 over 1 times 2/5. All right, let's clean these rascals up a little bit. That's a 1 and that's a 5. That's a 1 and that's a 1. And that's a 1 and that's a 2. Okay, so now I'm just going to do a little bit of multiplying. Let's say within that rascal right there, I'm going to get 5 minus, those multiply to a 1. And these rascals, be careful, you got a 2 here and a 2 here, so we get a product of 4. And 5 minus 1 is 4, all over 4, which equals 1. There's my final answer for question number 1. All right, let's try this other one. Let's wrap it up. And if I look at the 3 and the x and the 3 and the x, my LCD is going to be 3x. So I'm going to multiply again. This just has a value of 1. So we want to understand the basics behind this theme. And I'm going to distribute it to both terms on top, both terms on the bottom. And I really want to see this distribution step here on tomorrow's homework. When we, beyond tomorrow's homework, we're going to give you a little bit of freedom to maybe skip this step. But for tomorrow, it is a mandatory move. And so I'm going to say 3x over 1 times 2 over 3 plus 3x over 1 times 2 over x. 3x over 1 times 5/3 plus 3x over 1 times 5 over x. Okay, here's my favorite part of the problem. To me, this is the fun part, getting to cancel certain parts. So we'll say the 3 cancels with the 3. So the product of what's left would be 2x. And then the x kills the x, and the product of what's left is a 6. All right, what kills, we can say 3 kills 3. The product of what's left is a 5x. And let's say here the x kills the x, and the product of what's left is 15. Okay, now, we're not done. We're going to have some fun factoring what's left here. We have a GCF on top, and that's a 2. Divide by 2 gives you x. Divide by 2 gives you 3. On the bottom here, our GCF is a 5. So if I divide by 5, I get an x, and divide by 5, I get a 3. Bada bing, bada boom, my final answer is 2/5. What a great answer. Well, now that we've gotten a couple under our belt, I'd encourage you to feel free. If you're feeling pretty confident, by all means, try this one on your own. Great time to hit the pause button and give it a whirl. I'm going to consider the denominators of my minor fractions. And we got the 4x and the 2x and the 4. And remember, the least common denominator is the smallest term that all of the 8 and the 4x and the 2x and the 4 will divide into. So I'm going to say 8x is the smallest term that they'll all go into. So all I'm going to do is I'm just going to distribute my 8x to both of the numerator terms, both those minor fractions as we like to call them, and both of the minor fractions in the bottom. So this takes a little bit of time, but we're going to just be patient and we're going to rewrite it. So it's 8x over 1 times 3 over 8 plus 8x over 1 times 1 over 4x. And 8x over 1 times 7 over 2x plus 8x over 1. So you can see these are going to kind of look a little lengthy, but they're going to clean up so nice. Really, really nice. And here comes my favorite part. Let's say the 8 kills the 8, and if I multiply what's left here, whoops, I got to cross that one out, I'll get simply 3x. Just really be careful. Stay organized the entire time so that we don't lose any of the important pieces. Let's say that x kills the x, and that the 4 kills the 8, and it becomes a 2. All right, if I multiply what's remaining there, I'm just going to get a 2. All right, coming into the lower left-hand corner, we'll say x kills the x. 2 goes into 8 4 times. And if I multiply what's left, I'll get a 28. And let's see, 4 goes into 8 twice. Multiply what's left, and I get 6x. Okay, I do think we have some factoring to be done here. I don't think I can factor the numerator, but I can factor the denominator a little bit. I'm going to pull out a 2. And let's see. Pull out that 2. Divide the 28 by 2, I'll get 14. And divide the 6x by 2, I'll get 3x. So I did get it factored, but then nothing canceled. So I'm just going to wrap it up and say that is my final answer. So as we go forward here tonight, the only thing that's really going to change is our denominators of these minor fractions are going to progressively get a little nastier and a little nastier. So I'm going to look at the 4 denominators I have now, and between the 2 and the x squared and the 2x and the x squared, I'm going to say that 2x squared is my common denominator. That's the smallest term that everybody divides into or goes nicely into. So I'm going to just go ahead and distribute it to all the 4 terms. And let's see what we got here. 1 over 2 minus 2x squared over 1 times 2 over x squared. I should probably make that minus sign a little more bold. And 2x squared over 1 times 3 over 2x minus 2x squared times 3 over x squared. All right, here comes the fun part. Let the canceling begin. All right, let's say 2 kills the 2. What do you have left? You've got an x squared minus. Let's say x squared kills x squared. What do you got left? I got a 4 because that was the product of what was left. All right, here's where it gets a little more interesting. All right, 2 kills the 2. Now this x is going to kill one of those x's, but you still have an x that's still alive in the numerator. So we multiply what's still remaining, and you end up with a 3x. And then we come over here and we say, well, x squared just kills x squared. Multiply what's left. 2 times 3 is going to give me 6. Do you have any factoring to be done? Yes, 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 we do. The numerator is a difference of 2 perfect squares. And the denominator has a GCF of 3. Divide by 3, you get x. Divide by 3, we get a 2. Look at that. We got some identical binomials. So my final answer is going to be x plus 2 over 3. Wrap it up. There's our answer. All right, let's go get ourselves another big bear. And again, I want to encourage you, if you're feeling remotely confident at all, go ahead and try this one on your own. I'm going to consider the denominators, and I'm going to say that 5x squared is my LCD. Again, what's the value of this rascal? It's just a value of 1, and I'm distributing a 1. So I get something that looks like this. Distribute it to each term. Got to stay focused here so we don't make any careless mistakes. I think we're strong enough mathematically to really do well with this topic. We just got to stay focused. We got to stay on our toes. We want to eliminate and avoid any careless mistakes. All right, here we go. We're feeling good. Let the fun begin here with the canceling. So let's say 5 knocks out the 5, multiply what's left, and we're going to end up with 2x squared minus x kills an x, but you still got 1 left. So we've got 10x is the product. What do we got here? Let's say x kills an x, 5 kills the 5, and we get an x left because of that rascal right there. And x squared knocks out x squared, and we get a 5. We do have some factoring. What's your GCF in the numerator? I see a 2x. So if I divide the first term by 2x, I get x. Divide by 2x, I get a 5. On the bottom, it's simply x minus 5. We do have identical binomials. So we knock them off, and 2x is my final answer. Well, as I promised you, things were going to progressively get a little uglier. For the first time, we have 5 minor fractions, 3 minor fractions in the numerator, and 2 more minor fractions in the bottom. So I'm just going to, it just means I got more work involved. And what do you think the LCD should be? Do you want to go with 3x, 6x? You know what? I think we got to up the ante. I think we got to go with 12x. So here's what I want you guys to do. Let's go ahead. Let's hit the pause button right now. I want you to distribute that 12x to each and every term and go ahead and see what cancels and see if you can simplify it all on your own. Okay, so I've already gone ahead. You can see that I've distributed the 12x to all 3 minor fractions on top and both of the minor fractions in the numerator. And I've gotten this big hunk of awesome math right here. So now I'm going to begin my favorite part. We're going to start canceling. And let's say 12 cancels the 12, and you multiply what's left there, you're going to get x squared. 6 goes into 12 twice, so we get 2x. And x knocks out an x, so I multiply what's left there, and I got 24. Come on down to the bottom. 12 knocks out 12. Multiply what's left, and we'll get x squared minus, okay, now the x knocks out the x. The 3 goes into the 12 4 times. If you multiply both of the 4s that are still alive, you'll get this. Now, look at how much fun we're going to have factoring this. We've got a basic trinomial in the numerator. So I'm going to factor it into the product of 2 binomials. I know I need an x times an x, and now I'm just trying to think of 2 numbers that add up to 2 and yet multiply to negative 24. So I know I need 2 numbers with different signs, and the bigger one's going to be a positive number. So I'm thinking positive 6, negative 4. And on the bottom, I got a difference of 2 perfect squares, x plus 4, x minus 4. We do have identical binomials that we can cancel, and so our final answer is going to be x plus 6 divided by the quantity x plus 4. Parentheses are optional, but just remember we cannot cancel the x's because it's part of a binomial. They're in jail, so to speak. All right, so we're down to our last 2 problems, and here's a great note. We're just saying, hey, if the denominators of the minor fractions become more complex like we're seeing here, make sure we factor. All right, so let's underline that. Let's make sure we're factoring them first, just as we did when we were adding and subtracting in the previous lesson. So right here, this one cannot be factored, this one cannot be factored, but by golly, this one right here really, really has to be factored. So let's go ahead and factor that one out. So I just totally brought down the 2 minor fractions in the numerator down, and then in the denominator we're going to have the 12x minus 24. Notice I'm not factoring the numerator. We said we had to factor the denominator, and that's going to be what, x minus 4 and x plus 2, because those are the 2 numbers that add up to negative 2 and multiply to negative 8. Okay, so we've got this big major fraction, and what's the LCD going to be? Looks like my common denominator is going to be the quantity x plus 2 and the quantity x minus 4. So you can see how we've gone from having monomials for denominators to these feisty binomials for denominators. And now all I'm going to do is I'm going to go ahead and I'm going to distribute the LCD to all of the terms, all the minor fractions. And again, I want you to go ahead, I want you to try the distributing on your own and see if you can get some good stuff to cancel out. Okay, so I want you to double check yours with mine to make sure that I didn't make any careless mistakes. So what I did is I took this rascal and I distributed to both of the minor fractions on top. I took this rascal and I distributed it to the one minor fraction on the bottom. And you'll notice, I've got my big plus sign in the middle of the numerator that corresponds to this big plus sign. And everything else is going to fall into place. And we're going to get some really nice things to cancel out here. Again, this is my favorite part. Let's say that the quantity x plus 2 cancels out the quantity x plus 2. So what I've got to do is I've got to distribute the 4 into the x minus 4 here. So that's going to give me 4x minus 16. Then a big plus sign in the middle. And you'll notice the x minus 4 cancels the x minus 4. Now we got to grab the 2 and distribute. So it's going to be 2x plus what? Yeah, plus 4. Good news here on the bottom. X plus 2 cancels with x plus 2. The x minus 4 cancels with the x minus 4. And we're simply left with 12x minus 4. So now I'm just going to combine like terms in my numerator. The 4x and the 2x give me a 6x minus 12 all over 12x minus 4. And I'm just going to factor it with some GCFs. My numerator, I'm going to pull out a 6. My denominator, I'm going to pull out a 4. And that's going to give me 3x minus 1. And the best thing I could do is I could say, well, if I reduce the 6 and the 4, I'll get a 3 here and a 2 here. But that's the best I can do. So I'm going to wrap it up and call that my final answer. Alright, we're going to chunk this one up. Every once in a while, I'm going to pop in and show you my work at about approximately at the halfway point and so forth. But again, I want to give you guys a lot of independence here to try this one on your own. Identify your common denominator, but again, you're going to have to factor this denominator the best you can before you can identify that common denominator, and then you're off and running. So let's see what you got. Okay, so I'm about a third of the way through the problem. You'll notice I got my denominator factored here into x plus 6, x plus 2, and that was exactly what my LCD was. I got my x plus 6, my x plus 2 all over my x plus 6, x plus 2. So the next thing you're going to see me do is go ahead and distribute that rascal all the way through and set myself up for some nice canceling. Okay, so here I am. I've distributed that LCD to each of the terms, and I want to tell you right now, let's really be on our toes and watch out for that big minus sign. But let's cross that bridge when we get to it here in a few seconds. Let's cancel out the x plus 6's. Now I got to distribute the x through the x plus 2, and that's going to give me x squared plus 2x. All right, now x plus 2 kills the x plus 2. Now I've got to distribute the negative sign through there, so it's going to be minus x minus 6. And then we get to cancel everything down here, and we simply end up with x squared minus 4. And I'm going to go ahead and, well, you know what? I don't want to get ahead of myself. I don't want to go too fast, so I'm just going to write that down. Now in the numerator, I'm going to combine my like terms, and I'm going to get x squared plus x minus 6. Now it's time I've successfully eliminated all the minor fractions, of course, so now I'm just going to get everything factored completely. X plus 3 and x minus 2. On the bottom, again, difference of two perfect squares. So we're going to cancel out the identical binomials. And my final answer is going to be the quantity x plus 3 divided by the quantity x plus 2. And there's nothing more to factor or cancel, so I am done. So ladies and gentlemen, nice job hanging in there tonight. Let's use good terminology in our groups tomorrow when we're working with our friends and our partners. Let's talk about major fractions. Let's talk about minor fractions. Let's talk about LCDs and distributing and being nice and neat and organized and just being really crisp and clean. And I think if we include all those little ingredients, we're going to have a high degree of success tomorrow. So good luck, and we'll see you tomorrow.